looking at worked example 6.1c. So this time our charges are arranged in a triangle, not in a straight line. So we're going to have to be a little bit cleverer. Not a lot cleverer, just a little bit. Excuse me. Yes, it is early morning here on the farm. So we've got positive 5 microcoulombs, positive 5 microcoulombs. Micro is by 10 to the negative 6. Your data booklet has a list of all the prefixes and what their values are, so don't panic if you don't remember. And this one's negative 5. So this is going to be attracted towards A and towards B because we're looking at the force on charge C. So it's pretty straightforward. Here it is. So we have got, this is going to have a force on it going this way and a force on it going this way. And very conveniently, these are at a right angle to each other. So it makes it easy a bit later on. Right, so it's just straight this formula. The force of A on C is 1/4 pi E naught QQ R squared. Don't forget to change your R into meters, and we get 90 newtons towards A. Now, if you're smart, you'd say, all right, that's plus 5, 5 centimetres apart. Plus 5 minus 5, 5 centimetres apart. Plus 5 minus 5, 5 centimetres apart. This other force must be the same size. I wasn't quite that smart this morning. It's a bit early. So it's 90 as well. So we've got 90 plus 90 at right angles to each other like that. So then it's just a matter of adding them together, top to tail, so top of this one, tail of that one, and get the net force, just Pythagoras, 127 newtons, and it's going to go directly up the page. This is an isosceles triangle, so that's 45 degrees. So that's super cinch. Righto, the next one uses the same diagram, 6.1d. It's using the same diagram as before, but this time they want the force on B, and it's going to get a little bit trickier. So we already know this one force, right? Because the force of B on C is equal to the force of C on B. So straight away I've got that force, so I just need to calculate this one. Same rule as before, remembering, so you had to scratch it out, to change it to meters. I've been a bit slack and not written it out first. 44.6. So I've got 44.6 and 90. It almost ended up like a right angle triangle in my drawing, but that was just a poor drawing. So now we don't have a right angle triangle. So you've got a couple of choices. You can use this rule if you happen to know this rule off by heart. I wouldn't know that rule off by heart, so I would be stuck. I'd leave this one the way it is, and I would break this one up into a component in that direction and a component in this direction. So I'd split this into a horizontal and a vertical component, add or subtract as the case may be this one, and recombine them, which would take a lot longer than doing it like that.